Hi students, this is another question for helical gear students. First of all, I can read the question and we can identify what are the given data. So you please write this question and solve this in your notebook. The following data refers to the design of a helical gear drive. And the following data are: first one, power transmitted 34 kilowatt at 2800 rpm of pinion. Then speed ratio is 4.5. and the number of teeth on pinion 18. Then third one, helix angle 25 degree, pressure angle alpha is equal to 20 degree stub. Then next one, material for both pinion and gear is medium carbon steel, whose allowable stress may be taken as 230 megapascal. So here they given that the given material or the material for both pinion and gear are same. So we can identify the first step from here, that is the strength factor. That is, the design is based on pinion itself. So that we can discuss later. Then next, pinion diameter is limited to 125 mm. Then the question is, determine the axial thrust on the shaft and check the gear for dynamic and wear load. So we have to find the axial thrust and check the designs of our values are safe or not. So we can write the given data like this. That is, we can denote P is equal to 34 kilowatt and the N1 speed of the pinion, that is equal to 2800 rpm. Then I is equal to given, that is speed ratio 4.5, Z1 18. Then helix angle beta is equal to 25 degree and alpha is equal to 20 degree stub system. Then diameter D1 is the maximum of 125 mm. Then sigma D1, which is equal to sigma D2, that is equal to 230 megapascal. And as we know that I, the speed ratio, that is equal to N1 divided by N2, we can find the value of number of teeth on gear from this equation. Using this equation, thus we will get it is 81 teeth. Then after that we can go for the design, identify the weaker part as I discussed in the question section. Since the both pinion and gear are made of same material, so pinion is weaker. So we can take this equation and we can directly take the design is based only on pinion because the materials are both same. Then using this equation we can find the virtual number of teeth, that is 12.52a. Z is equal to Z divided by cos cube beta. So using this equation we can find the virtual number of teeth. Then next one is ZE2, that is similar to virtual number of teeth on gear. We can take that values 108.81, that is equal to 109. Then we can find the module, that is from equation 12.60. Using this equation we can find the module. For that we need that equation, that weights, that is V is equal to pi dn by 60. Using this equation we will get 18.33, that is in between 10 to 20 meter per second. So from there we can, from the data book itself, we can take the value for CV between 10 to 20 meter per second. Thus we can find value of CV. After that we can take the value of Ft is equal to 1000 PCS divided by V. Here we need an assumption, that is assume that gear is working for 8 to 10 hours service and consider it is for a moderate shock. So from table 12.8 we can take CS is equal to 1.5. After that Ft, we can calculate Ft, that is equal to 2782.32 Newton. Then next we can calculate form factor Y, that is equal to pi into Y1. Y1 we can take for a subsystem, that is equal to 0.175 minus 0.95 divided by ZE1. Using this equation we can find the value of Y. Then we can assume that value K for a helical gear it is assumed to be 15, and CW assumed it as 1.15. We can take this value from the table 12.21. After that, using these values we can find the value of module, that is Mn is equal to 2.19. Okay. Then we can standardize or we can round off that value to 2.5 using the table 12.2. Then we can check the width, that is face width. B is equal to 15 into mn, that is equal to 37.5 mm. So B minimum from this equation 12.5 for B minimum is equal to 1.155 mn divided by sin theta. So we can check that value, that is equal to 21.37. Using that equation we will get that value is equal to 21.37. Since the B is greater than B min, so the calculated value B min is equal to lesser. So our design or taken value is safe. Next one, check for sigma D1. So we know that Ft is equal to sigma D CV By Mn divided by Cw from this equation 12.59. And using this equation we can substitute all other values other than sigma D. So we can check for sigma D. That using that equation we will get sigma D is equal to 176.31. So which is lesser than 230, that is the given value. So again our design values taken values are safe. Next we can find the face width, that is equal to, we already calculated, that is equal to module into 15, that is equal to 37.5. Next we can find the value of dynamic load Fd. So using this equation 12.62 we can take this Fd, this you can use this equation and find the value of Fd. There are lot of unknown parameters in this equation, so using that table or using just below that equation all these values are given, or using this table we can find all the parameters in the equation. So using that equation we can find out the value of Ft, that is equal to 10.71 kilonewton. And next they ask in the question itself, they ask what is the value of dynamic tooth load. So from this equation 12.64 we can take the we can find the value of dynamic tooth load. Fw is equal to d1 bqk divided by cos square beta, and the diameter d1 they are given by, that is equal to 125 mm, and the ratio using this equation that is also given just below the equation, and using this equation we can find the value of q. After that, surface endurance we can take it from 12.36 d. From that equation we can find the value, from that equation we can find the value of sigma es, that is equal to 260 megapascal. BH is not given since both gears are made steel. Assume then E is equal to, assume that E is equal to 2.1 into 10 raised to 5 megapascal. Then using this equation we can take that value and substitute all other values here. Then we will get alpha n. Then we can find the value using this equation. Using this equation we can find the value of k. Then use that value is substituted in the Fw. Thus we will calculate the net wire load, that will be 1348.65. But here the Fw is less than Fd. The pinion is subjected to a rapid wear, so the surface harden should be given for the higher BHN, otherwise that gear section will be failed. So we have to find what is the actual BHN we require for the safest design. So we can check for Fw greater than Fd. So using that equation, Fd we already calculated. Using that equation we can find the value of k. Then using this section we can take BHN, BH1 and BHN1 and BHN2, both are 300. For the safety design we can take these values. And next the axial thrust, that is the another section given in the question. Axial thrust, or we can denote it as Fa, that is equal to Ft into tan beta. So we need only beta here, and that is also directly given in the question. So from this equation, and that equation is already shown in the textbook, that is 12.51. Using this equation we can find the value of Fa also. Okay, thank you student.